So we don't know what we're running.
I don't know with that other setup. I've never done it that way. Brandon, you should get that. It will be emailed to you, and I think you'll get notification as well, like on your Google Plus page. So nothing with the little bell icon in there. Oh, that one right there. There we go. Yeah, so just grab, there should also be like a Google Plus page for this. So you guys want to make sure you read the mic high. And if you go over to the side and to the left toolbar, you see the 3 dots at the bottom?
Yep.
Should be things right there. So the link might actually only be available on Andrew's. Yes.
Oh, wait.
So you see at the bottom right corner where it says links?
That's the YouTube, right?
Yes, it's the YouTube and the Google Plus event page. So if they go to the Google Plus event page, that's where they'll be able to ask the Q&A.
Oh, that's different than before, right? When we had that?
Yeah, but I don't know if that was like a regular Google Hangout or if that was Google Hangouts on air, but that one allows...
Oh, can I just hit the link so we can post it?
Yeah, he's...
Okay.
But that's where they have the ability to view it from 2 different ways. Mm-hmm. And once you guys are done with this, it'll automatically record into the account.
Okay, email sent to your BU account. Really?
Yeah, it's kind of a pain to get set the first time.
Well, we thought we spent a while yesterday doing it.
Yeah, we had the same thing with poetry. I don't know what they did either. I don't know.
We literally just went to Google Hangouts and
Yeah.
we said, like, let's set it up for tomorrow at noon. And there's even a countdown. You can go to the YouTube site.
Yeah.
It's like starting in, a day. And it's like it was counting down literally like every second.
I've never done it that way. So
I tested 2 of them.
Yeah, like going through these exact steps has been the only way I've gotten it to work every single time. So.
But then you have to do it like you do it then the day that you go. So that's what I liked. I liked the idea of like we set it up yesterday.
Yeah. Yeah.
And the idea was we just come into that.
Yeah.
Okay. So it seems they can't ask questions on YouTube now.
They can't on YouTube.
And we're thinking of the other one. How does it?
So we're doing something totally different. That's what
yeah, I'm not sure how that was set up. So.
I mean, you can also see how many people are watching the YouTube stream or in the chat, and nobody else has said anything.
Is there anyone in the discussion forum?
Nobody's in the discussion forum. So it might just be that nobody's around.
Okay. Well, do you guys think you're fine now? Do you want me to stick around, or?
I guess we're fine, right? Are we live? We are. You guys can see on YouTube.
Yeah.
Okay. Then I think we're fine.
Okay. Great. Yeah. If you guys have any more problems, feel free to
okay.
Street.
Thank you, Vanessa.
No
Thanks
problem.
for running over.
Yeah. No problem. This is the first time I've been able to do that. Everyone else does it at home, so this is easier.
Okay.
can't see it. You did it.
There's no way I'm gonna be able to do that again.
We'll figure it out. Let's figure out what the problem was the first time.
I agree. I mean, as a learning exercise, like, I wish now that I would have,
Tested it as well.
like,
Or-
yeah, we should have, like, actually done one, like, yesterday.
Yeah. Where is the YouTube one?
I posted an update on the course.
One viewer, is that different than one of you?
Probably.
Well, it's where I can see both of you joined in. Oh, but I
But
can do
I
a
don't
viewer
have-
on YouTube.
I don't have the YouTube one yet.
Oh, that's probably Brandon.
So I just clicked on it and now it's okay, they can comment underneath the video on YouTube, and those will also be saved. And you can reply to them and whatever.
Okay, on the YouTube, should I have that open?
You probably don't need to since Brandon and I have it,
Okay.
but if they comment here, it will be saved and there's a reply feature on that.
Got it. I think we want them saved if that's
Yeah.
possible. Oh, someone else was trying to hang out, I think, maybe. It looked like when I was just looking at mine. It's not on this page, it's on the,
On the YouTube?
when I went to this, no, it's like the Google Hangouts
Oh.
Air. It said Namel, Ahmad just joined the Hangout.
He's been in for a while, but when I saw that, but he didn't show up on anything, so.
I'm alive, I should.
Yeah, it looks like Cole had tried it on it too. Or something at least.
How you doing? When's the chance to get in here to paint that wall?
Hi.
Good.
Would you like to do that right now?
Look, it's nobody's in there.
I don't think anyone's in there right now. Yeah. Still no one?
Nobody in the second one. Nobody but us watching the video.
Hi!
The common thing is on the surface, the harpoons didn't work.
There have been bit at work.
Yeah.
I think we already launched it.
I am, yeah. Alright, are you going back to your office? Oh, okay. I'd say if you delay through that, I'll go with you, but Do you think we should go a little bit longer? Because we
Are you thinking of just giving up on this?
no, not I don't no. Well, I'm not going to give up, but I would wait. I would go a little after 1.
Yeah.
Yeah. So yeah, or you can go. If you want. So.
I can do that.
Okay. Yeah.
Cool.
I could probably go at like 12:50.
That's fine. Yeah.
Yeah, it landed, but I guess the things that they were going to stick into the comment didn't work.
Oh.
So I don't know how it's still there.
I heard someone said that it was. Maybe they were.
It's Twitter feed, so it doesn't work. Twitter doesn't lie.
I have a video call from Nobel Ahmed some point ago. You missed a video call 3 minutes ago.
Do you recognize the name?
No. Four viewers now, so
Okay, that's Brandon in the. Oh, yeah. What?
Nabil Ahmed is one of our students.
He's no longer watching the YouTube video.
yeah, now we're back down to 3.
Is it
2,
really just
yeah,
sitting
2.
there?
Before viewer.
hello to those who are joining us here at the Alien Worlds office hours. I'm Professor Andrew West here, sitting in my office here at Boston University. If you guys have questions or would like to contribute to the discussion, please write in the chat boxes, and I have Brandon and Leanne who are sitting here with me who will feed me questions that I can chat with about. Hopefully those of you on saw that there was some exciting results from this morning that the European Space Agency landed its probe on Comet, and we're just getting back some of the first results now, but it looked like it successfully at least landed on the surface of the comet, which is the first time humans have done that, and one of, again, the small number of terrestrial or solid objects that we've actually landed some object on. So pretty exciting day for Alien Worlds. But please let me know if you have any questions or there's anything you'd like to talk about. Welcome to the office hours. We're sorry that it got started a little late. We had some technical difficulties getting the links set up correctly. But I think we're all online now, and hopefully more of you will join us.
Hello? Hello?
Welcome again to the office hours for Alien Worlds. If you have any questions, please let us know. Send us a chat, and we'll be happy to answer them. We're also happy to extend this a little bit beyond um, the normally scheduled time, since it took us a little bit to get all set up. So please let us know if you have any questions.
Sir, I have a question. Hello? Oh, okay.
Awesome. our first question. Um, so the question that we got from the group is, what is a singularity? Singularity is often we hear when we talk about black holes. And so a singularity is a single point in space, a point that has no volume, um, so no size, no radius, no volume at all. And so a black hole is actually a single point in space. It's an object that has mass but no space, and so we call it a singularity because it is a single point in all of space. And you actually get that, at least in the case of a black hole, because as we saw in the Module 2 demo when we talked about how gravity really works, gravity just bends space-time. And so if you have a really massive object, it can actually take that sheet and bend it so far in that the edges actually touch. And you actually make an object that has mass but no volume, and that's what a black hole is. So imagine taking that sheet and stretching it all the way down until the edges pinched in on itself. Then you would have a singularity.
Oh yeah.
Other questions?
Yes. Wormholes in general, what they are actually?
So I think the question here is actually, what is a wormhole? And a wormhole is a kind of hypothetical idea where you could actually bend or alter the fabric of space, and maybe space and time, where you could cross between space in a very interesting way. This is not something that has been observed. It's not something that we see a lot in science fiction, but it is a way that you could essentially imagine going between two regions of space that are separated by a very long distance. If you could somehow alter gravity to take that fabric of space and bend it such that those 2 points of space, which normally are separated by very large distances, if you now bend space-time, let me grab a piece of paper, something like this, and if I had two spaces where my two fingers are, if I could bend space like that by harnessing the power of gravity and then kind of tunnel a hole between them, that would be just like what a wormhole is, at least hypothetically. But this is not something we can at least currently do, and it's not something we have ever observed in nature. But it's something we see a lot in science fiction, particularly in the latest this Interstellar movie that just came out. That's one of the ways that the astronauts in that movie are able to travel to actually a different galaxy. Great questions. even though it's the time that we're supposed to end, we'll stay here for a few minutes longer in case there are a few more questions. So please ask a few more questions if there are. Since we started late, we're happy to stay for a few more minutes and see if you have any additional questions. So please let us know. I was asked to repeat the last questions because there was some technical problems on someone else's end. I'm happy to do that since there aren't any additional questions. I'll say that two things again. A singularity is a single point in space, a place with an object with no volume. And often when we have a black hole, that's where we encounter singularities. An object that has mass, so it has gravitational pull, gravitational force, but it actually occupies no space, it occupies no volume. And that's because, remember when we talked about in Module 2 demo, how gravity really works. It bends the fabric of space. And so you can imagine if you had a really massive object, it would bend space so much that the space would actually collapse in on itself. And you would have actually, therefore, no space. And we call that a singularity. That's exactly what a black hole is. The other question was about a wormhole, which is a kind of hypothetical idea of how if you could harness gravity in a certain way, you might be able to bend the fabric of space so that 2 points in the universe separated by very long distances, say my 2 fingers here, you could bend space-time or bend space, you could maybe get those 2 points to be much closer to each other by passing through some kind of tunnel in space. We call that a wormhole. Of course, that's just only in science fiction right now. We don't know how to do that. And we've certainly never observed that in nature. But it's something that we see quite often in science fiction, including in the movie that's currently out in movie theaters, at least here in the United States, the movie called Interstellar. Other questions?
Lots of questions. Relativity.
Yes, all of this has to do, certainly the bending of space has to do with Einstein's theory of relativity. There are actually a couple different theories of relativity. There's the general theory of relativity that speaks towards how we consider things like the shape of space and how space gets affected by things like gravity and how that affects actually both space and time. There's also the special theory of relativity, which has at its core the fact that there is a universal speed limit in the universe, that we can't travel faster than the speed of light. And anytime you get even close to traveling the speed of light, some very funny things happen. The time that you feel compared to the outside time is actually different, and actually the clocks actually run a little bit slower for someone who's traveling close to the speed of light or a significant fraction of the speed of light. But things like mass scales and length scales also are altered. So some very funny things happen when people or anything travel close to the speed of light. And that's actually been tested. We know that when we shoot radioactive material at speeds that are close to the speed of light, we notice that the decay rates actually change. So that's actually something that's been tested here on Earth. For those watching, we'll probably stay on another 4 or 5 minutes or so. So if you have additional questions, please let us know. We will certainly do this again. We may even try to schedule another one because of the technical problems we have. But I hope you'll ask us plenty more questions in the discussion forums, and certainly join us for our next office hours, where we'll be able to spend an entire hour answering any questions that you have, either about the course material or about astronomy and science in general. We'll at least try to answer them to our best abilities. There's another question about weightlessness. I assume that the question is about how you feel maybe weightlessness when you're in space. And that's actually a kind of funny thing. It's not that there isn't gravity, it's that you don't feel, there still is gravity pulling to you. So for example, if you were on the International Space Station, let's say, and you were an astronaut, you're still, of course, feeling Earth's gravity. But it turns out that you are, the International Space Station is moving so fast to stay in orbit that you actually are accelerating kind of actually towards the Earth, and the International Space Station is accelerating towards the Earth in order to actually stay in orbit. And so the counter to that is actually the centrifugal acceleration that you actually feel, which we would call the inertia, actually makes it feel like you don't have weight. So the fact that you're moving so fast around the Earth actually makes you feel like you're floating. Imagine if you were on the edge of a merry-go-round going really, really fast. You feel like you're actually being pulled away from the center. That's exactly what's happening if you were on the International Space Station or on the old space shuttle or on a Soyuz capsule. You'd actually be shooting around so quickly that you actually feel like you're floating. But in fact, the Earth's gravity still is pulling on you. It's your motion in orbit and your very, very fast motion in orbit that actually makes it feel like you don't, makes it feel like you actually are weightless. So you're not really weightless. In fact, in some you hear a lot of people at NASA or in the European Space Agency talk about it actually being microgravity. So you're not really totally weightless. Your motion around the Earth, in this case, actually makes it feel like you don't have very much weight. All right, well, I think our time's just about up. Thank you for the few questions that we got. I'm sorry that we weren't able to start this quite on time. We will make sure that we do that again next time, and maybe we'll put in another office hours just so we make sure we can answer a lot of student questions. Please keep the questions coming. Please use the discussion boards. Look forward to chatting with some of you again in the near future. All right. Have a good rest of your days or nights, wherever you might be.